Next, we'll look at some special lines, and the way we know that they're special when we look at the equation is that they only have one variable. This only has x. It does not have a y. So it is going to be a line because the exponent's 1, but it will be special. If you want to memorize, x equals some number is always a vertical line. So x equals 2, find the 2, and draw a vertical line through it, and you're done. I have a hard time remembering which of these is which is vertical and which is horizontal. And if that ever happens to you, just make a quick little chart. Right? Your x has to be 2 for all your points. We'll do 3 points. Since there is no y in the equation, you can have any y, and you don't even have to do the math. So we'll just do 0, 1, 2, and then to graph 2, 0, and 2, 1, and 2, 2, and as soon as you see a couple of them, it will remind you which direction the line goes. Our next one is also a special line. It is y equals -1. There is no x. Anytime you have y equals some number, it is a horizontal line. So we find the -1 and just draw a horizontal line through it, and that will be our graph. If you forget which way it goes, you know it's special but you forget, we'll just make a quick little table. This time our y has to be -1. Since there is no x, we can put any x we want. So 0, 1, 2. So over 0 down 1, over 1 down 1, over 2 down 1, and you can see these are lining up horizontally. Next, we'll do a couple of nonlinear functions. So they're not going to be a line, and to do this we will use a t-chart. Now for lines, we most of the time would use 3 points, or if we had intercepts we would use 2. When you don't know what a picture is going to look like, you're going to need probably more than that. You have to cover all kinds of numbers to see where the graph is. So we're going to do y equals x squared, and we will pick for the x because it is the one not isolated. So let's start with 0. So y equals 0 squared. 0 squared is 0. All right, we'll pick a 1. Y equals 1 squared. 1 squared is 1 times 1 is still 1. We'll pick a 2. So y equals 2 squared. 2 times 2 is 4. Right, and let's switch and pick a couple of negatives and see if we can tell how this graph goes. Right, let's pick a -1 for x, and anytime there's an exponent, you're going to plug in with parentheses. I didn't put them here because it was positive, but you have to when it's negative. So if I'm plugging in a -1 and I'm going to square it, the sign will go to the power. It is -1 times -1 gives me a +1. And we'll do a -2. So plug it in, and the sign will go to the power. -2 times -2 will give us a +4. Now let's see what this looks like. So 0, 0, 1, 1, 2, 4, right, -1, 1, and -2, 4. And this graph is going to be a parabola. We'll look at one more nonlinear function with a t-chart. This one has an absolute value in it. We are going to pick for x because it is not isolated. So say if we pick a 0. So y equals absolute value of 0 plus 1. Absolute value of 0 is 0 plus 1 is 1. And then let's pick a 1. absolute value of 1 is 1, plus our 1 will give us a 2. All right, and let's go ahead and pick a 2. All right, I'm getting short on room here, so we'll plug the 2 in. Absolute value of 2 is 2 spaces. 2 plus 1 is 3. Now, I'm clean this off and we'll pick some negatives. All right, so if we pick a negative 1, so y equals absolute value of negative 1 plus 1. Do your absolute first. Absolute is distance, so it's going to be 1 unit. 1 plus 1 is 2. All right, and then let's pick a negative 2. So y equals absolute of negative 2 plus 1. Absolute is distance. That will be 2 spaces plus 1 will give us 3. All right, now let's plot and see if we can tell what it looks like. So 0, 1. Don't go over, go up 1. Right. 1, 2. So go back to 0, 0. 1 and up 2. Right. 2, 3. Go back to 0, 0. Over 2, up 3. 1, 2, 3. Right. And back to 0, 0. Negative 1, 2. And back to 0, 0. Negative 2, 3. And this is a standard absolute value graph. It is going to look like a V. And so we can connect it here. You could have tried a couple more points if you want. But notice you need to do some positive and some negative so you can tell where the graph is when you really don't know.